This video is brought to you by leXsolar, understanding new energies with teaching systems and training systems for school, technical training and further training, and the YouTube channel Innovative Technology and Energy Transition. Electric cars are basically divided into two groups, hybrid and fully electric vehicles. Hybrid vehicles have both an internal combustion engine and at least one electric motor. Fully electric vehicles are powered only by one or more electric motors. Hybrid vehicles are further subdivided into plug-in hybrids and normal hybrid vehicles without a plug. Plug-in hybrids can have the battery charged externally, while the others can only be charged by recuperation, which means feeding energy back when the vehicle breaks. Plug-in hybrids also generally have a significantly larger battery capacity. In the following, we'll focus on fully electric cars that no longer have an internal combustion engine and thus do not produce any local CO2 emissions. First, let's take a closer look at the structure of electric vehicles compared to passenger cars with internal combustion engines. The main difference is, as the name suggests, the electric motor. Compared to the combustion engine, not only one electric motor is used, in some models several smaller motors are used. The use of electric drive results in numerous other differences in the entire drivetrain compared to the combustion engine vehicle. On the input side, the motor requires electrical energy instead of fuel. In all electric vehicles, this comes either from battery or a fuel cell. Here we will look at the battery electric vehicle, since this solution for passenger cars is currently gaining acceptance all over the world and significantly more battery than fuel cell vehicles are being sold. Instead of a fuel tank, a battery is installed here. Since a battery supplies a DC voltage, but the engine is operated with an AC voltage, an inverter is needed here. In the combustion engine, after the engine, you always need a complex gearbox with several gears, usually at least 5, with automatic transitions, often even a few more, as well as a clutch. This is much simpler in the electric car, usually designed with only one gear, which means that no clutch is necessary. Technically, it is also possible to use a direct drive, which does not need a gearbox at all. Depending on the design, there is also no longer any need for differential gearbox that distributes the drive power to the individual wheels. In practice, however, simple transmissions and clutches are usually used, as this increases the efficiency for the vehicle. The entire exhaust treatment in the car, like catalytic converters, particulate filters, as well as the entire exhaust, is omitted, since the battery does not produce any local emissions. No changes to other parts of the vehicle, such as the rest of the chassis or the body, are necessary. In the following, we will take a closer look at the technical and economic implications of these differences. Let's first look at the energy storage in both cases. A fuel tank is a relatively simple component and inexpensive. Lithium-ion batteries used today, on the other hand, are comparatively expensive and heavy. For example, the lithium-ion battery in today's electric cars usually weighs 300 to 500 kg, whereas a fuel tank usually weighs less than 100 kg even when full. The differences becomes even clearer when one considers the energy densities. For modern lithium-ion batteries in electric vehicles, this is around 250 watt-hours per kilogram, while for gasoline it is between 12,000 and 13,000 watt-hours per kilogram. Due to the difference in efficiency, however, the difference in range is not that great, with values between 400 and 600 kilometers for the electric car and 600 to 1000 kilometers for the internal combustion vehicles. Another difference is refueling. With internal combustion vehicles, the tank is usually full again in 1 to 2 minutes. With electric vehicles, charging takes much longer. At fast charging stations, partial charges between 50 and 75% are usually possible in 20 to 60 minutes. Full charging a bit longer. In addition to these technical data, the mining of raw materials, especially for the necessary lithium in the batteries, is often criticized. Here it will certainly be necessary in the future to improve the mining process and also to work on recycling lithium from the old batteries. Apart from energy storage, the electric car offers a lot of advantages. For example, the rest of the powertrain is much less complicated. Today, a passenger car combustion engine has around 2,500 components that have to be deployed, manufactured and assembled. By contrast, an electric motor consists of only around 250 parts. In addition, the gearboxes are much simpler if they are necessary at all. The weight differences in energy storage are also partially compensated by the lack of or a smaller gearbox. In addition, the electric motor is significantly lighter, while an internal combustion engine with gearbox can quickly weigh 200 kg. Modern electric motors with the same power can be built with 10 to 20 kg. The maximum efficiency of electric motors is in a range of 90 to 98%, while an internal combustion engine is more in the range of around 40%, which also means that significantly less energy has to be stored in the battery than in the fuel tank to achieve the same range. Transmission losses are also reduced and significantly fewer raw materials are needed for the engine and transmission, which also have to be mined. The significantly simpler powertrain also reduces the effort and cost of maintenance and repair for the electric vehicle. For example, oil changes are no longer required. Air and oil filters no longer needed to be replaced, and brake wear is also significantly reduced thanks to recuperation. The elimination of exhaust gas treatment also means that no AdBlue, new exhaust or new particulate filter is required. Technical functions as torque vectoring, in which torque is distributed differently to the individual wheels of the vehicle in order to obtain driving dynamics advantages depending on the driving situation, are much easier to implement in electric cars, in some cases without extra components. You can find more interesting videos like this here on the YouTube channel Innovative Technology and Energy Transition. You want to understand new energies or teach them to others with teaching systems and training systems for school, technical training and further training? Then check out the leXsolar homepage now.